Hello, everybody. I'm sorry I'm out again. This time I tested positive for COVID. Yay! Hopefully it won't be too long before I'm back. But in the meantime, let's start our new unit because today we're doing more derivatives, but this is Unit 3, Derivatives, the sequel. So, anyway, so today we're going to learn about chain rule. We're going to spend a couple of days on chain rule. And really, there's nothing going to be new on day 2. It's just going to be more practice because it takes a little practice. So let's talk about the chain rule. All right, then. Okay, so the chain rule is used to differentiate a composition of functions. Biggest mistake students make with chain rule is they don't identify when they actually have to use it right. So that's what I want to do first. Let's make sure we understand what a composition of functions is. So I have a little table here, and in the table, I want you to identify which of the following represents a composition of functions. And if it is, find the inside and outside functions. And let's go ahead and let g of x be the inside function, and f of x can be the outside function. And so I have a little table here. So if you think you know what I mean, you can go ahead and pause the video right now and start. And if not, I'll do number 1 for you. So number 1, is this a composition of functions? Do we have one function inside another function? And yes, it looks like 2x plus 1 is inside the sine function. So I'm going to say, yes, this is a composition, and my outside function would be sine, and my my inside function would be 2x plus 1. So that's what I mean. So go ahead and pause the video right now and try the other ones. Okay, I'm assuming that you paused the video. So I'm just going to run down these really quickly. The second one, we can definitely see 3x plus 7 inside the square root. So I'm going to say, yes, this is a composition. 3x plus 7 is inside the square root function. The third one, this one's a little sneaky, but remember that cosine cubed x is the same thing as saying cosine x to the power of 3. So yes, we have a composition of functions, and cosine is inside the cubed function. The second one is not a composition. It's just 2x squared plus 7. There's no inside and outside function. And the last one, a lot of people miss at first, but it is a composition. You can think of x plus 3 inside this fraction. And remember, when I say inside, it means that 2x plus 1 is inside of sine, so we replace the x with it. 3x plus 7 would go in place of this x. Cosine x would go in place of this x. X plus 3 would go in place of this x. Okay, so that's a composition of functions. So what is the chain rule? Right here. So the chain rule is, it's going to sound weird at first. You get used to it though, you really do. If y equals f of u, I always love that books use fu. If y equals f of u is a function of u, and u is a function of x, then, first of all, we can rewrite y like this. Because if u is equal to g of x, then I can take this g of x and put it inside u, and then y looks like this. So that's the first thing. Chain rule doesn't really say that part, but I just added that in. But if that's true, then dy dx is dy du times du dx. It's kind of like the du's cancel out, and you get dy dx. What does this mean? Well, it means this. If you want to take the derivative of a composition of functions, then take the derivative of the outside, leaving the inside the same, times the derivative of the inside. And this is the key right here. So, derivative of a composition is derivative of the outside evaluated at the inside times derivative of the inside. So let's take a look at how this works. So I have this example right here. We're going to look at the ones that I had in that table above. And after I do the first one, honestly, like at any point, if you're like, oh, I think I can do this, go ahead and pause the video and try. You can see I have the next one on the screen right now. But let's see. It's definitely a composition we already identified. We can see that 2x is inside the sine function. So to take the derivative, to find dy dx, we take the derivative of the outside. The outside is sine. What's the derivative of sine? Cosine. But you leave the inside the same. Don't touch the inside yet. And then you multiply by the derivative of the inside. And what's the derivative of 2x plus 1? Why, it's just 2. And then, really, we can't do anything with this except we can move that 2 out in front, not make it so awkward. And there it is. There's our derivative. So, derivative of the outside evaluated at the inside times derivative of the inside. There it is. All right. So if you think you can do it, go ahead and pause the video, try the second one. And now we're going to work it out. You can see I have the next one here too. Feel free, again, at any point, pause the video, try these on your own. All right, f prime of x. To take the derivative of this, we have 3x plus 7 inside the square root function. So, to take the derivative of the square root function, that's the outside function. Now, eventually you want to get to the point where you don't actually have to write this out. If you can get that fluency down so you don't have to think of it like this, or you don't have to actually write it out, you can just think about that, and that's awesome. But we're going to take the derivative of the outside. The outside is the square root function. We're going to use power rule. Multiply by the exponent, subtract the exponent by 1, but keep the inside the same, times derivative of the inside, which is just 3. And there it is. We can then either write our answer as 3/2 times 3x plus 7 to the negative 1/2, or we could put that 3x plus 7 to the 1/2 in a fraction in the denominator because it's a negative exponent, and I can even make it a square root. Honestly, you could leave your answer either way. I'm going to go ahead and box the last one. You can leave it as a line above. Doesn't matter. The one thing, though, I do want you to kind of keep in mind, which is why I kind of like this way better, is just remember that 3x plus 7 is in the denominator when you see that negative exponent. So whatever makes this equal 0 doesn't make f prime 0, it makes f prime undefined because it would put 0 in the denominator. So just kind of keep that in mind. All right, try the next one. Actually, try the next two. All right, I'm going to assume you paused the video. So we have cosine inside the cubed function. So inside the cubed function, to take the derivative of the cubed function, multiply by the exponent, subtract 1 from the exponent, but keep the inside the same, and then multiply by the derivative of the inside. And can clean this up slightly. Let's make that negative 3. We can make it cosine squared x sine x. And there's your answer. And then the last one, that's x plus 3 inside the fraction. I'm going to just write this out. Again, if you can get to the point where you don't have to do this, that would be best. But it's just easier for me to explain if you can see it. But remember, this means x plus 3 is to the negative 1 power. So I'm going to apply the power rule, multiply by the exponent, subtract 1 from the exponent, keep the inside the same, and in this case, the derivative of the inside is just 1, so I don't even really need to multiply it or show it. And then I can just clean this up a little bit. Let's put that x plus 3 in the denominator. It's got a negative exponent. There it is. There's our answer. All right, here's some trickier ones now. Examples using product and quotient rules that also involve simplifying. Now, honestly, this isn't going to use anything that you don't already know. So if you think you got the hang of this and you're up for a challenge, go ahead and pause the video right now and see if you can do this, and see if you can fully simplify too. And then we can compare answers. So with this one, I definitely have a product. So when I work this out, I'm going to have to use product rule. However, V also happens to be a composition of functions. So we've got a lot going on here. So let's try it. So U dV. So to take the derivative of the second, I got to use chain rule. Outside function is a square root function. Multiply by the exponent, subtract 1 from the exponent, keep the inside the same, multiply by the derivative of the inside. Whew. Oh, I forgot negative. It's a negative 2x. Let me rewrite that so the negative doesn't get lost. All right, so we got that. And then it's plus v. Now, because I'm writing this as a fractional exponent, I'm going to actually change v to also have a fractional exponent, du. So let me label everything. This was u. All of this is dv plus v du. So at any point, if you need to pause the video to kind of chew on this, go ahead. That's the derivative. Now we're going to simplify. And I'm going to simplify using factoring out the with the smallest exponent, because I see a 1 minus x squared in both of these. This one's to the negative 1/2. This one's to the positive 1/2. I'm going to factor out using the smaller exponent. I also see a 2x in both of these that I can factor out. So when I factor it out, my common factor, I'm going to take out a 2x, 1 minus x squared to the negative 1/2. So that's my GCF. Now, when I factor out from this term, the 2x is gone, but I still have the negative. The 1 minus x squared to the negative 1/2 is gone. So I'm going to have negative 1/2 x squared left. 2x is gone, but I had the negative. This is all gone. I still have the 1/2 x squared. So that's the first term. And then in the second term, so I got a plus sign, 2x has been factored out. And then I have this. Remember, to find your new exponent, subtract the exponents. 1/2 minus negative 1/2 is positive 1. So this is just to the first power. I don't even need to write that. And then actually something else I should have done in the beginning, but sometimes it helps to do it in steps. I'm also going to factor out the fraction. So I'm going to factor out a 1/2. I'm going to factor out a 1/2. and then I still have the 2x, 1 minus x squared to the negative 1/2 that I factored out. When I factor out the 1/2 from here, I still have the negative x squared left. And then here I'm going to have a 2 in order to keep it equivalent. You can think about 1/2 times 2 gives me 1. So it's back there. And then I can clean up what's inside. I'm just going to move this down a little bit. So first of all, 1/2 times 2, that's just 1. So I have 1 x times 1 minus x squared to the negative 1/2. And then I have negative x squared. I'm going to distribute the 2. And so finally, let's see what I got here. I'm going to write it as a fraction now. So I have an x. I have 1 minus x squared in the denominator inside a square root. And inside those parentheses, that all simplifies to 2 minus 3x squared. And there's my answer. It's really going to help us. I want you to start now trying to get used to factoring and doing this simplifying here. Because what we do in Unit 4, we're going to finally be doing something with these derivatives. Unit 4 is applications of derivatives, and it's going to help if it's in this factored form. It's going to help a lot if it's in this factored form. So I want you to start getting used to taking out the common factor. So let me back up here. We'll go this far. So once we took the derivative, we had 2 terms. We had this whole term and this whole term. And there was a 2x in both. And actually, if we had gone ahead and multiplied these together, it would have saved a little bit of time. But we can definitely see there's a 2x in both. And then there was a 1 minus x squared in both, and we factored out using the smaller exponent. And then to find the new exponent, we subtracted. 1/2 minus negative 1/2 is 1. So try to get in the habit of that. Okay, so now let's try this one. I may need a new page. I don't know if it's going to fit. This one's kind of ugly because, oh my goodness, we've got quotient rule, and inside quotient rule, we're going to have chain rule. I'm going to go ahead and actually, we're going to add a page. No, I don't want to do that. That's what I want to do. Okay, I'm going to go ahead and move this to a new page. I want to make sure I got plenty of room. Sorry, they updated the app and I haven't added a page that way in a while. Okay, let's take the derivative of this. So, if I call the top u and the bottom v, then we know for quotient rule, we're going to take it slowly here. Quotient rule says bottom, and actually I'm going to go ahead and write this as an exponent. So bottom times derivative of the top minus top times derivative of the bottom. Multiply by the exponent, subtract 1 from the exponent, keep the inside the same, times derivative of the inside. And then the bottom squared, it would be to the 1/3, but when I square it, it's going to be to the 2/3 power. So bottom times derivative of the top minus top times derivative of the bottom. over the bottom squared. All right, so there's the derivative. Now how do I simplify this beast of a thing? Let's actually do something we didn't do in the previous problem so you can see what I was talking about. I'm going to just clean up each term a little bit. Um, we don't need the 1, so that numerator, that's just x squared plus 4 to the 1/3. And then over here, I have 1/3 times 2. I can make that 2/3, and then I got an x squared. 2/3 x squared, and then x squared plus 4 to the negative 2/3, all over that same denominator. Okay, I'm going to focus on the numerator. So the numerator, I have an x plus 4, or x squared plus 4 in both. I'm going to factor out using the smaller exponent, so I'm going to take that out. I'm also going to factor out a 2/3. Actually, I'm going to factor out a 1/3. I'm going to factor out 1/3 x squared plus 4 to the negative 2/3. So what am I left with in that numerator? Well, in the first term, if I factor out a 1/3, dividing out a 1/3, I'm going to have 3 left. 1/3 times 3 gives me the 1 that's in front of there. I'm also going to have an x squared plus 4 to some power. And if I subtract 1/3 minus negative 2/3, it's 3/3, which is 1. I just have an exponent of 1. In the second term, I factor it out. I factor a 1/3 from 2/3. I still have 2 left. I still have the x squared left, but I factored all of that out right there. And then it's still over x squared plus 4 to the 2/3. So this guy, I can think of it as this. Just put the negative 2/3, put that exponent. It's negative, so I'm going to put that factor in the denominator. I'm also going to clean up this numerator a bit. If I distributed the 3, I'd have 3x squared, but minus 2x squared is just x squared. And then the 3 gets multiplied by the 4. And then the bottom, still x squared plus 4 to the 2/3. And so finally, I will have x squared plus 12 over. Remember what happens when you multiply with the same base? I'm going to multiply with this times this. We're going to add the exponents and get to the power of 4/3. And there is our answer, factored and simplified. Remember, factoring doesn't mean simplifying, so that's why I say factored and simplified. But compare that answer with, let me see if I can get it up here. There we go. Here was our initial answer. You can even think of this right here. This looks much nicer than this. It still looks kind of ugly. There's a lot going on, but it looks much better than this. So it really helps if you can factor it. And like I said, for Unit 4, it's going to be much more manageable, and you're going to have to factor it, actually. There won't be an option. So get in the habit of it now. Okay, so there's that one. Here's some more examples. We just got a couple more here, and and then I have 3 more examples for you. They're just all the same. So honestly, at any point, if you're like, I got this, I want to start the homework, feel free. You got the notes you can look at. I'm going to go ahead and continue on with the video and keep working these out. But you might be able to, just by looking at the notes that I post, figure out how to do them. So anyway, going to try these. Let's go for it. So this one, it's not product or quotient rule like the ones above. However, we have functions inside functions. Remember that this means the sign of x squared plus 7 inside the fourth power. So our most outside function is to the fourth power. And then we have sine in that. And inside of sine, we have x squared plus 7. So to take the derivative, we're going to start with the most outside function, which is to the power of 4. So we're going to multiply by the exponent. We're going to keep the inside the same and subtract 1 from the exponent. And then we take the derivative of the inside. But to do the derivative of the inside is chain rule again. So we're going to take the derivative of sine, keep the inside the same, and then multiply by the derivative of the inside. So take the derivative of sine, keeping the inside the same, times the derivative of the inside. And at that point, we're done because no more compositions. Whew. And let's see how we can clean this up. Not a whole lot, but we can multiply the 4 times 2. I'll put the x in front. And we can write that as sine cubed. Sine cubed of x squared plus 7 cosine x squared plus 7. And there is the answer. All right, and the last one. This one's product rule. We got this times this, and each product or each factor is a composition. So dy dx. First times derivative of the second plus second times derivative of the first. Ooh, almost didn't have room. And at this point, let's factor. I have this term and this term. Remember, terms are separated by plus and minus signs, not in parentheses. Each term, let's see, I have an 15. They don't have common factors. But I do have a 3x plus 7 in both and a 2x plus 1 in both. And I'm going to factor out using smaller exponents. So I have a 3x plus 7, and the smaller exponent on that is a 4. And I have 2x plus 1, and the smaller exponent on that is a 3. So what am I left with? Well, I had 5 of these, but I took 4 out, so I still have 1 left. 3x plus 7, and that's multiplied by 8. And I still have the 15, and I had 4 of these. I took 3 of them out. I have 1 left. And I didn't say it in the first term. I also took all of those out. And in the second term, I took all of those out. And dy dx. I have my GCF that I factored out. And now I'm just going to distribute and try to combine like terms here. I'm going to have a 24x plus 56 plus 30x plus 15 and combine my like terms. I got 54x plus 71. And there is no common factor in this, so I am done. And again, see my answer is in a nice factored form. It's going to be much easier to deal with in the next unit. All right, my last example. Try this one on your own. This one's going to use a trig identity, just warning you. All right, so where the tangent line is horizontal is where the derivative equals 0, so I got to find the derivative. So f prime of x. The first term is not a composition, so it's just derivative of that is just 2 cosine x. The second one is a composition. I got 2x inside cosine. So first of all, the derivative of cosine is negative sine. Keep the inside the same, times derivative of the inside. So just cleaning it up ever so slightly. The derivative is this. So we need to figure out where this derivative is 0. However, how do we do this? Because that's got an angle of x. This has an angle of 2x. Well, do you remember your identities? Sine 2x is 2 sine x cosine x. So using that, I can write everything in terms of an angle of x. I still have that 2 there, but then 2 sine x cosine x. And if I keep going with this, I can factor out a 2 cosine x. I am left with 1 minus 2 sine x. Set each factor equal to 0. And we're looking for where cosine x equals 0 and sine x equals 1/2. Now I'm going to go back to the original problem because I kind of glossed over this, but it did give us an interval of 0 to 2 pi, so we only care about those answers. So within one rotation of a circle, where does cosine equal 0? It's going to equal 0 at pi over 2 and 3 pi over 2. Where does sine, oh, I forgot my x. Where does sine of x equal 1/2? My, using all students take calculus, sine is going to be positive in quadrants 1 and 2. In quadrant 1, the reference angle is pi over 6. In quadrant 2, it's going to be 5 pi over 6. So there are the answers. Pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. At these 4 values of x, the original graph has a horizontal tangent line. Alrighty, so that is it for me. Hopefully this wasn't too painful. I'm really sorry that I'm not there. And I'll see you when I get back though. Bye.